Hello guys, welcome to Limgautik's YouTube channel. Today we are going to look into numerical integration and go through trapezoidal method. So here is a numerical integration and what we usually do with numerical integration. We use it to approximate area under curve. Okay, so if you are given a fx and limit a to b, you can use any method of numerical integration to get the approximate area under curve. Okay, so this area we denote it by a equals to limit of a to b fx. Okay, so there are two types of numerical integration, which is a closed loop integration and open integration. So for closed integration, there's three types: trapezoidal method, Simpson's 1/3 and 3/8 rule. And then for open integration method, there's Gauss quadrature. Okay, so let's move on to the first method, trapezoidal method. Okay, so trapezoidal method is basically you use a linear function to approximate the area under curve. Okay, so since you are using a linear function, therefore, this approximation is exact when y is first degree polynomial. So what is meant by exact? Meaning that the approximate area under curve is the exact area under curve. Okay, so if you're given a function y or fx and limit a to b, you draw a line between the beginning and end point. So this is a approximate area under curve, which is given by the area of a trapezium. Therefore, you use the area of a trapezium method, half times side times width, this plus this. Okay, so this is the area of a trapezium. Okay, so what is degree of polynomial? We need to know this as this is important when we move on. Okay, so example, if I say one function is in the first degree of polynomial, meaning that y is equals to the summation of terms where the maximum degree is 1. So you can see the example here, all the x is to the power of 1. Okay, so if I say the degree of polynomial is 2, meaning that the maximum power is 2. So you can see that all the example here, the maximum x is 2. Okay, so let's move on to an example of approximation method to determine the area under curve. Okay, so if you're given fx equals to 3x plus 4 and the limit 1 to 2, so find the area of this curve using trapezoidal method. So we just plug in the formula, the trapezoidal method, trapezoidal area, plug in the values. So here, when f1 and f2, you just plug 1 and 2 into fx. So here is 3 times 1 is 3, 4, and 3 times 2 is 6, 4. Okay, so you got 17 over 2. So this is using a trapezoidal method, but let's use a traditional method where you get the exact value by integrate the function. So why is this numerical integration so important is that sometimes a function might be hard to integrate, so you might use this method to find the area under curve. Okay, so if you use a traditional method, integrate this, you will get the exact same answer as fx is a linear function. Linear function meaning that the maximum x is to the degree of 1. Okay, so let's move on to the second example. Now fx is in the degree of 2. So later on you can see that the approximate area is not the exact 1. Okay, so if you use the trapezoidal method, sub everything inside like just now what we did. Okay, you will got 9.6. Okay, so here let's go through it again. Okay, So you just sub 1 into fx, so you got this part, and then you sub 2 into fx, you got this part. Okay, so you got 9.6. This is a approximate area. Okay, so using a traditional method by integrating fx, you got the exact area of it, which is 9.2667. So if you compare this and this, it's different, right? Okay, so that's it for today. Thank you for watching. If you all would like to see more at math and engineering videos in the future, hit the subscribe button. See you all next time.